Okay, recording is started. So let me start officially. So good morning, students. This is your second class of elective one, professional elective one, and that is railway engineering. Okay. So in the last class, that is the first class, we have gone through a brief overview uh, of railway engineering. Fine. That means we have discussed about little bit about background, or you can say the history of railway engineering, history of Indian railway. Okay, and you can say from where the first railway started in India, who have started. Okay, you can also go through Google. Okay, or also you can go through a student portal. The link is already given in the student portal. You can go through that, and you can also refer book. The name of the book is also given in the syllabus. If you have the syllabus, you can look carefully at the bottom. You will see some reference book or textbooks already given there. You can also you can also follow a textbook of railway engineering written by Saxena, that is SC Saxena and SP Arora, and other books are also available. There is no hard and fast rule that you can follow this one only. You can follow any standard textbook of railway engineering. Okay, so for that, you can also go through the knowing the background of railway and railway engineering or history of railway in India, okay, by yourself also. It will just build your foundation on railway engineering. Okay, fine. So today we are going to discuss on a technical point of view. We're going to discuss some component of. Wait a second. Okay. Yeah, we're going to discuss some technical aspect of railway engineering. So in the last class, we already discussed about railway component. Okay, so I already told you in a railway engineering comprises of two things. One is the base where the train moves. Fine, a train have two component. One is locomotive, another one is wagon. Locomotive actually was the engine. The engine is known as locomotive. Okay, and the rest part is called wagon. Okay, and they move along a rail. Okay, fine. So this thing already roughly I have given the information to you in the last class. Fine. So let's go again. Let me share the screen again. Wait. Okay, can you see the screen? Is it visible?
Yes, yes, sir.
Okay, okay. So I think you are familiar with this drawing. So it's not. Yeah. So you can see this is a cross-sectional view of a railway track. So this is, you can say, this is a train. Okay, and train is moving uh, over this rail. Okay, laterally spaced rail, and the train have a wheel. This you can see the black color conical shaped wheel, and which is connected with an axle. Okay, so with this axle, these railway wheels are connected, and this with this wheel, a rail move along the railway line. You can say fine, and the rail is placed over the sleeper. You can see this is a laterally spaced component. Okay, so it is called sleeper, and sleeper is placed over. Okay, wait, someone is waiting. Wait. Okay, so the rail is placed over sleeper. Sleeper is placed over ballast. Okay, then after that sub ballast. Okay, and you can also say a ballast. Generally, a blanket. Blanket is basically made of coarse aggregate. Okay, all are basically a coarse aggregate, and maybe blanket is a kind of a fine aggregate. Finally, there's subgrade soil and subsoil. Fine, and in the basic idea of placing this this component of railway in such a manner. The main idea about to transfer the load. You know these things. Basically, why these so much things are placed one above another. The main objective of placing one above another is to transfer the load of the train or the passenger, okay, into the subsoil. This is the main purpose. Fine, and it should not get failed by any load or downward vertical load. Fine. So you may be asked a question: why rail is provided over sleeper and why sleeper is placed over ballast? Okay, why this sequence is so important? Because we cannot place this rail below sleeper. We cannot place sleeper below ballast. Okay, so basic idea about the placing all these components in such a manner is that you have to transfer the load in a larger area. Okay, so first of all you have to know within a train. First of all, the train have a dead load. Okay, along also the wheel and the axle also have some weight. Fine. The I'm talking about first dead load. Okay, the dead load, or you can say the self weight of the train. Okay, and additional to the dead load, uh, there are passengers. Okay, furnitures. All these things are moving. Things are there. So these all are combined with a dead load plus sleep loads present in this within a train. Okay, so this is called, you can say, a moving load. Okay, okay. So this moving load, we need to transfer this moving load into the subsoil. Okay, so first of all, this moving load is um, transferred through the axle to the rail. Okay, via axle, the load is transferred, the moving load is transferred to rail as a point load. Okay, that means they are acting as a point load. That means the moving load of the train is transferred to rail through the axle as a point load. Okay, so this point load from this rail is transferred to the sleeper as a line load. It is distributed over this line. That means over the sleeper. Okay, and after the sleeper, this line load is transferred to the ballast as a area load, and similarly, it is again goes to the subgrade soil and subsoil as a area load. Okay, and of course, area load is more safer, and our main target to convert this moving load into area load so that it can distribute it through the ground subsoil, you can say. Okay, so you have to remember that the rail converted the moving load of the train into point load. Okay, and the sleeper, in the sleeper, the point load from the rail is converted as a line load, and the line load is converted into area load from sleeper to ballast, and from ballast to a blanket, you can say, or subgrade soil or subsoil. Is it clear right till now? Is it clear? I need some response. Okay.
Sir, will you explain what exactly is ballast and sub-ballast?
Ballast and supply. We are going to explain one by one thing. Okay, in coming classes. Okay, we're going to discuss about today. In today class, we're going to discuss about rail. Then we're going to discuss about sleeper, ballast, everything in coming classes. Fine. Till now, you have to just know the location of the ballast or location of the sleeper and rail thing. Up to this, is it clear or not? Till now, is it clear?
Yes, sir. Yes, sir.
Okay. So for today, we're going to discuss about only the rail part. That means the rail where the the rail the train, you can say, move along a track. Fine. Okay. So can you see this? So basically, we're going to discuss about only the rail part only. So you can see we are in this particular diagram. You can just imagine a train moving along this rail. So this is a rail. It is a cross-sectional view. Okay, you cannot see the length of the rail. You can see the cross-section of the rail. Okay, this is a rail. Okay, and this is the sleeper. This is the ballast, sub-ballast, and subgrade. Okay, so if I give a general definition of rail, so rail profile is a cross-sectional shape of a railway rail perpendicular to its length. Okay, that means since you are seeing only the cross-sectional view, length is in the perpendicular direction. So if I say the railway profile, the rail profile is the cross-sectional shape of the railway line. That is, you can see the cross-section. This is a rail. Okay. Another definition is also there, I guess. Let me check. Yeah. So rail are the member of the track laid in two parallel lines to provide an unchanging, continuous, and level surface for a movement of train. To be able to withstand stresses, they are made of high carbon steel. So this is a basic definition of rail. Okay. So rails are the member of the track laid in parallel lines to provide unchanging, continuous, and level surface for the movement of train. So you can see the rails, these are two rail, you can say. These rail are placed parallel to each other. Okay. And they are placed in such a manner that um, to provide unchanging, continuous level surface. What is the advantage of these 3 points? Unchanging means what? They are not change. They are not the rail. The railway line will not allow the train to go in different direction. It will always restrict in one particular direction. Fine. And continuous also, it is a continuous line, and the level surface always in the level surface, so that the rail should not go bent. Fine. So rails are the members of the track laid in parallel lines to provide an unchanging, continuous, and level surface for the movement of the train. And they are made of high carbon steel since they are the direct contact with the rail, and the first load is you know, you know come to the rail only. So that they must made of high carbon steel, and they must have some strength, high strength. Fine. So if I say in general function of rail, why rails are provided? So here you can see the points are given here. So rails provide a continuous and level surface of the movement of train. They provide a pathway which is smooth and has very little friction. The friction between the steel wheel and the steel rail is about one-fifth of the friction between the pneumatic tire and a rigid and or flexible surface. That means a normal, you can, if you consider a normal tire, a truck tire, and a normal surface, that means road, whatever friction will produce during the movement of a truck tire over the flexible surface or rigid surface, that friction will be one-fifth in case of railway track. Okay, the friction is very less. Okay, so the rail serve as a lateral guide for the wheel. So why it's called lateral guide means what? That means they restrict, or they are not allowing the rail to move in a lateral direction. Okay, they will not allow to go in this direction, left or right. They will go only straight. Okay, so they serve as a lateral guide for the wheel. Wheel means the train wheel. Fine. Okay, next, rail bear the stresses developed due to a vertical load transmitted to them through axle and wheels of rolling shock, as well as due to braking and thermal forces. So there might be a chances of braking, there may be a chances of thermal forces. Thermal force means there is a temperature because of the friction, okay, or maybe because of the atmosphere, the temperature may increase. Okay, the thermal force also uh, acting on the rail. Okay, as well as the vertical load is transmitted. Vertical load means the load coming from the train, either dead load, or it's a combination of dead load and live load. Okay, the vertical load transmitted to the rail through the axle. Okay, that means they have to withstand that vertical load coming through the wheel or axle. Fine. Next, they carry out the function of transmitting the load to a large area of the formation through sleeper and ballast. So the main purpose of placing the rail is to convert the load, okay, and distribute it in the larger area. So distribute in larger area mean this subgrade soil, okay, or subsoil. So it's converted the rolling load of the train into point load, and finally it come to the sleeper as a line load. Then it will go to area load. Okay, so it's transferring, uh, you know, transferring the point load into the larger area finally. So this is a basic function of rails. Now if I say the type of rail, okay, is it working? Let me check. Okay, wait. Okay, so if you want to know the type of rail, so basically there are three types of rail. So you can see the cross-sectional view here. So we have double-headed rail, bull-headed rail, and flat-footed rail. Okay, so basically you will see a flat-footed rail even here. Whenever you go outside, you go next time you go. Whenever you go outside, go to the railway track. Check closely what type of the railway track is there. What is the cross-section? If possible, try to try to see. Okay, so here you can see from the name also it is the definition is very easy. Bull-headed means the both top and bottom part is it's like a dumbbell shape, na? So it's a bull-headed. Sorry, it's a double-headed. Sorry, it is a double-headed. So in a both side it is look like a head only. There is no foot. The top and bottom sides are similar size. Okay, so it's a double-headed. In bull-headed you can see the top part is little larger in shape compared to the bottom. So you can say bull-headed. Okay, and flat-footed rail here you can see the foot is flat, the base is you can see the normal flat. Okay, and if I set a component of a particular flat-footed rail which is usually used in India, so you can see the top part is called head, middle part is called wave, bottom part is called foot, and if I say the height of the rail it will count from the top to bottom, and you can see the angle made from this it is called fishing angle. Okay, and here in the wave part a fishing plate is connected. Now we are going to discuss about what is fishing plate. Okay, what is the purpose of fishing plate? Okay, so at this angle you can see that angle. This angle is known as fishing angle. Okay, it's look like fish now. This part is little bit look like a face of the fish. That's why it's called fishing angle. Okay, so if I let me give you some actual drawing whether you can see. You can see here it is a I think double-headed rail. Okay, you can see the cross section double-headed. The both top and bottom are almost equal. You can see. So they are double-headed rail. Let me see. Is there any other? Yeah, you can see also here. See? Can you see that drawing? This is a double-headed rail. This is your bull-headed rail and flat-footed rail. Okay. Let me see. Is there any other drawing is there? Even here also you can see. This is your flat-footed rail. You can see the foot is flat, where the top part is called head, bottom part is called foot, the middle vertical part is called web. Okay, so here you can see here this part. You can see if it is zoom in here, the larger view is given here. This is the fish plate. You can see this is the fish plate, and fish plate is connected in the web part. And what is the purpose of fish plate? To join two rail. Fish plate is connected. Okay, I'll show you a larger view again. Let me check. Is there not? Yeah, you can see. Here you can see. Uh, I think from this image you can understand very easily. This is rail. This is one the end of one rail. This is another rail. Okay, and these two rails are connected together by a fishing plate. So this is your fishing plate. Okay, which is connected along the web part of the two rail. Okay, the fishing plate is mainly used to connect two rail. Okay, here you can see it written here, and some gap is also left here. You can see end post is given. You can see the gap between two rail. It is left for some expansion. Okay, because of the excessive heat, the the rail bar may expand. Okay, so if for the expansion, this some joint are left. This is called expansion joint. Okay, some millimeter space is left here. Okay, this is rail and these are slipper. You can see some wooden slipper is placed over here, wooden slipper. And here you can see some bolt are fastened here 4 numbers of bolts are given here. This is your fish plate. Okay, they are
Sir,
ballast.
sorry, can you explain why
Pardon?
the gap is being?
क्या
Sir,
क्या?
can you explain again why we have a gap? Sir,
Which one?
थोड़ा
Which one?
gap क्यों है? Sir,
Okay,
gap
gap.
क्यों है?
You
2
can see
millimeter
this
gap
one left because of the expansion. Because see, it is made of steel only. Okay, because of the even in it is kind of physics. You already got in HS or in science class also. There is a possibility of expansion in case of steel or iron. Isn't you know this thing, na? In heating area, in heating atmosphere, there is a possibility of expansion.
Okay, sir.
Okay, so we have to leave some amount of space for expansion. If we closed, if we join together, it will not, it will try to expand and finally it will make some crack on the rail. Got it? So that's why for future
Yes, sir.
expansion, possible expansion, what some expansion gap is provided here. Okay, so this is your expansion gap. Okay, yeah. So here you can see it is a fish plate and this is a fishing angle. You can see, you cannot see here fishing angle in a cross section. You can see, and you can see the fastening. We are going to discuss about fastening also. These fastening are used to connect the rail with the sleeper. Okay, so there's a two kind of two component for join. One is your fishing plate. Fishing plate is used to connect to rail. Fastener or fastening is done to connect rails with sleeper. You can see. So whenever you go in field, whenever you go in the railway track, just look closely. Which one is where is the slip? Where is the fishing plate? Where is the fastener? Okay, where is slipper? Where is ballast? You will find every component in railway track. Okay, fine. So let me check any other. Wait. Yeah, this one already discussed. Yeah. So have you got the idea about different shape of the rail cross section? So well, what is the requirement of ideal rail section? Let's discuss about that. So a requirement of an ideal rail sections are as follows. What is the requirement of ideal rail section? The rail should have the most economical section consistent with strength, stiffness, and durability. That means a particular rail section must have a strength, stiffness, and durability. Next, the center of gravity of rail, a center of gravity of the rail section should preferably preferably be very close to the mid height of the rail so that the maximum tensile and compressive stresses are equal. That means it's better that the center of gravity of any, suppose if I use the flat footed rail, the center of gravity must go through the center and specifically it must come, the point of the center point must be at the midpoint of the wave. Okay, so that the compression and tension stresses are equal. Okay. Next, the rail primarily consists of a head, wave, and foot, and there should be an economical and balanced distribution of metal in its various components so that each of them can fulfill its requirement properly. The requirement as well as the main consideration for a design of these rail components are as follows. So we already discussed about different component of a rail, that is the head, wave, foot, height, and fishing angle. Fine, and fishing plate is connected over here. So some definitions are already given here. The head of the rail should have adequate depth to allow for vertical wear or vertical failure. The rail head should also be sufficiently wide so that not only is wider running surface available, wider running surface available, but also the rail has the desired lateral stiffness. Okay. Next, the wave part. The wave should be sufficiently thick so that or so as to withstand the stresses arising due to the loads bore by it after allowing for normal corrosion. Next, for foot, the foot should be sufficient thickness, should be of sufficient thickness to be able to withstand vertical and horizontal forces after allowing for loss due to corrosion. The foot should be wide enough for stability against overturning. So yeah, it is a basic idea about head, wave, and foot. The basic requirement of ideal head, ideal wave, ideal foot. Overall, you can say the ideal rail section. Okay. Now fishing angle. So this must ensure proper transmission of load from rail to the fish plate. The fishing angle should be such that the tightening of the plate does not produce any excessive stress on the wave of the rail. That means why fishing angle is provided, so that we already given here in this diagram. Let me check which one diagram. Wait, what? Uh, wait. Yeah, here you can see the front view. You can say fishing plate is placed. You can see along the web side. Okay, along the web portion of the rail. And here you can see the fishing angle. You cannot see, but you can just try to imagine the fishing angle is there. Okay, so fishing angle is provided such that the load from the rail is transferred to the fishing plate, and there should not be any friction between the fishing plate and the rail part. Okay, so fishing plates must ensure proper transmission of loads from the rail to the fish plate. The fishing angle should be such that the tightening of the plate does not produce any excessive stress on the wave of the rail. Okay? Then height of the rail. The height should be adequate so that the rail has sufficient vertical stiffness and strength as a beam. So there are for each and every component, there are some requirement for ideal head, ideal wave, ideal foot, ideal height, ideal fishing angle. So overall, ideal rail section. So this is very important part. Okay? Yeah, we can also say the height of the weight of the rail also. Through the weight of the rail and its section depend upon the various consideration. The heaviest axle load that the rail has to carry plays the most important role. That means the weight of the rail, what should be the ideal weight of the rail? It also depend on the load coming on the particular rail. That means the axle load. Okay, the heaviest axle load that is going to carry. The weight of the rail is depend on the axle load. Axle means you can say the vertical load. Now, if I say the standard length of rail, so theoretically, the longer is the rail, the lesser would be the number of joint and fitting required, and lesser the cost of the construction and maintenance. Have you got this idea? Theoretically, the longer is the rail, the lesser will be the number of joint. Of course, okay. Suppose I have a 100-meter track is we need to go for. Okay, if I have 10-meter rail, okay. Suppose we need to cover 100-meter. Okay, we need to prepare a railway track of 100-meter, but we have a rail of length 10-meter. Then how many rails would be required? Anyone?
10.
10, na? Means one direction 10, then other direction 10. That means 10, 10, 20, right? If I consider only one direction, if I use 10-meter length of rail, then we have to provide 10 numbers of rail. and for 10 numbers of rail, we have to give for different numbers of joint, isn't it? And for each joint, we need a fishing plate to connect two rails. Fine. And if I go for, say, if I go for 50-meter length, okay, if I have a rail of 50 meter, that means how many rail will require? Two. 150, then we just connect two numbers of rail having 50-meter length, just connect it. You can connect 100-meter, right? So for by this, we can use only one joint and one fishing plane only, or you can say both side two fishing plane. That means the longer is the rail, the lesser will be the number of joint, and fitting required also less. Fitting required means the number of required fishing plate, bolt, and all of everything will be less. Even the maintenance cost also be very less. So longer rails are economical and provide smooth and comfortable rides. Of course, because of the since in the joint we provide some gap, expansion gap. So because of the gap, okay, and there's must be some discomfort in the rail when you go through the train. Even you also, whenever you travel through train, you must have have experienced this kind of disturbance, isn't it? Even the sound of the train also, it's little bit not uniform. Okay, this is come from your gap, expansion gap. Okay, so longer will be the rail, the more numbers will be joined, more will be discomfort. Sorry, I'm giving a reverse one. Longer will be the rail, longer will be the rail, lesser will be your joint, and your comfort will be more. Okay. Wait a second. Okay. So longer rails are economical and provide smooth and comfortable rides. The length of the rail is, however, restricted due to the following factors. But we cannot, although the longer rails are uh, good theoretically, but it is not possible to uh, manufacture the, or you can say place or use the longer rail in practical. Why? So there are some drawback, or you can say restriction. You can say. So first restriction is what? The lack of facilities for transport of longer rail, particularly on curves. So in curve, you cannot provide a straight rail. Okay, so we have to cut the rail. So we cannot provide the longer rail in all places, especially in curve. Next, difficulties in manufacturing very long rail. Even in manufacturing a longer rail is also very tough. Although right now is going for a longer rail also. You can go for checking the railway ministry. They are manufacturing right now. Okay. Next, number three, difficulties in acquiring bigger expansion joint for rail, long rail. The longer the rail, expansion joint will be more. Okay, so but we cannot provide the higher expansion joint. We have to minimize that expansion joint. So difficulties in acquiring bigger expansion joints for longer rails also be there. Next, heavy internal thermal stresses is long rail also be available. So there is a restriction for using longer rail. But taking the above factor in consideration, Indian Railway has standardized a rail length of 13 meter, which was previously 42 feet. That is actually near about 12 or something. Yeah. For broad gauge, 12 meter. For meter gauge or narrow gauge, different even. So we are not discussing about gauge right now. We are coming in the class. Okay. There is a special term gauge. Okay, like what is broad gauge, what is mg means meter gauge, okay, this narrow gauge, we're going to discuss in coming classes, so don't worry about that. For now you can just concentrate here only. So Indian Railway is also planning to use 39-meter length of rail, even longer rail in its track system. Okay, so some information also given and new update here. So here this is all about the information related to rail. Okay, we have discussed about type of rail, what is the requirement of rail, ideal rail, okay, different component of rail, okay, what is the purpose of placing the rail, all these things. So this is all about today class. Let me close my sharing here. Let me wait. Okay. So is it okay now? Is there any doubt?
Sir,
Is it clear? See, railway engineering is not
yeah,
that tough. It's very easy. It's easy to understand, and it's more advantage is what you can go in the practical field in the railway track. You can see the thing by your own eyes. You will get the information very easily. Okay, even reading by yourself also you can understand. Okay, so I'm closing the.
sir,
Yeah,
sir, I have a question. Sir,
yeah, you can
we
ask.
learned about double-headed, bull-headed, and flat-footed. Sir, when do we use uh, do we have a specific type of place
Yeah,
for
yeah. That
where
is the
we
thing.
can
Now,
use
this is the thing.
double-headed?
You first find out by yourself, man. Okay, okay. This is a very simple thing. First, if you have any query for that, suppose you have asking about why we are not using double headed, why you are using only flat footed. Okay, there's some advantage. What there is that, isn't it? So it's I am giving you all your job. Find out that. Okay,
Okay, sir. Okay,
it's very easy to understand. Just go through your textbook, go through Google, find out by yourself. It will make you understand more clearly. Okay, it's up to you. Any
okay, sir.
other? Any other doubt? If not,
No,
then
sir.
I'll take attendance now. Okay. So I'll close my recording also. Then after close the recording, I'll take the attendance. Wait.